Hello, my young scientists. Today we are going to be talking about what is science. Part 1. Science comes from the Latin word scientia, meaning knowledge. It is this systematic endeavor that builds and organizes knowledge in the form of attestable explanations and predictions about our universe. Basically, it describes how the world is. Now, there's a checklist to figure out if something's scientific or not. Does it focus on the natural world? Does it aim to explain the natural world? Does it use testable ideas? Does it rely on evidence? Does it involve the scientific community? Does it lead to ongoing research? And does it benefit from a scientific behavior? Science does have its limits. Science does not judge. It does not make moral judgments between good and bad. It does not make aesthetic judgments, whether something is beautiful or hideous. Those are going to be individual, personalized opinions. So science does not judge. It also cannot tell you how to use scientific knowledge. Some sort of scientific knowledge can either be used for two ways. It can be used for good, or it can be used for evil. Again, that's going to be in the person to decide whether to use it for good or bad. And so science does not tell you which to use it. It just gives you what it is. Science also does not draw conclusions about supernatural explanations. So it does not really go into religion or the ideas of ghosts or spirits. It doesn't go there. They're not exactly explained by science, but they do touch science. How important are ethics in today's society? Well, it dictates how we use our scientific knowledge, whether we believe that it's going to be for the good or for the bad. Now, we do have ethical standards in science. Honesty is a big one. We must report scientific data honestly. We can't tweak it. We can't falsify it. We can't make it up. We can't say, well, if I just look at it this way. We have to report it honestly. You have to be careful in transcription and analysis of your scientific results so to avoid error. You want an independent analysis and interpretation of the results that is based on the data and not on influence from external sources. Basically, you don't want bias. You don't want to try to spin it, or you don't want to try and say, well, if I tweak this, it can come out to the way I want it. Well, things don't come out the way that you want it. You have to be honest in science and say what it is. You must be open and share your methods, data, interpretations through publication and presentation. You must have sufficient validation of the results through replication by doing it over and over and over again and getting the same results. And through collaboration with peers. Say, hey, yeah, come on over. Why don't you test this? Why don't you watch me do it? Why don't you try it? See if you come out with the same thing. You also must have proper crediting of sources, information, and ideas. Give credit where credit is due. We also have a moral obligation to the general society. We must tell them if something's going to influence them directly, both good and bad. We also have to weigh the rights of the humans and animal subjects that are in our experiments. So, scientific ethics must record accurate data, never mislead, falsify, or make up any information. We must obey the laws of our society, and all test subjects must have full disclosure, whether that's, human testing, anything. We must tell exactly what's going to happen. So, offhand, I'd say that you are suffering from an arrow through the head. But just to play it safe, I'm ordering a whole bunch of tests. Again, science, we don't just make observations. We experiment with it. We make tests. We see what else there is. And we do that through the scientific problem solving known as the scientific method. Now, this is one way to do the scientific method. You can add more steps, but this is the basics that you need to do. You need to observe and ask a question. You must research and gather information to form an educated hypothesis. A hypothesis is not a random guess, but it's educated. You use that information that you have gathered to predict, to make a hypothesis an educated guess. Then you test the hypothesis with an experiment. And you gather data through that experiment, and you must analyze it, look at it. And then you draw a conclusion. Conclusions can go two ways. You can either not support your hypothesis, in which you then have to go back and revise your hypothesis and test it again and analyze it again and come back to conclusions. You keep on going that route until your conclusion supports your hypothesis. And once your conclusions support it, you need to go out and share. Let people know about it. Hypothesis is a possible explanation of events or set of observations. Not a random guess, but an educated one. It serves as a prediction or an action and result, and it is always in an if-then format. If my biology students study, then they will achieve an A. Variables. A variable is something that can affect or change the outcome of an experiment. The independent variable is the factor which the scientist changes, or the thing the scientist changes. The independent variable is the thing the scientist changes. The independent variable is the thing the scientist changes. The independent variable is the thing the scientist changes. Yeah, you'll hear me say that over and over again. You'll get it down eventually. Next is the dependent variable. Is the factor that changes because of that independent variable. It's the one that's being measured in the experiment. So the dependent variable is the one that's being measured. The dependent variable is the one that's being measured. The dependent variable is the one that's being measured. Yeah, I'll say that a few more times too. You'll get used to it. All experiments are designed to focus directly on one problem. And to have a valid scientific experiment, there can only be one variable. Yes, one thing changed. One. So, let's try it out. See, the hypothesis is, if you study for 30 minutes a night, then you will achieve an A in biology. Well, let's try to figure out which is the independent variable and which is the dependent variable. The independent variable is the thing the scientist changes. What did you change here? If you study for 30 minutes a night, then you will achieve an A. What did you change? What do you think? Minutes studying. That is what you changed. How many minutes you're going to study a night. Check out the dependent variable. The dependent variable is the one that's being measured. The dependent variable is the one that's being measured. What are we measuring here? Well, we changed the minutes, and then you will achieve an A. So the grade in biology. When you are looking at data from an experiment, you tend to put it in a graph a lot of the time. And our independent variable is always going to be on the x-axis, and our dependent variable is always going to be on our y-axis. So what you are changing, what the scientist is changing, is always going to be along the bottom, and what you are measuring is always going to be along the side. Now make sure you have a few things. You always need a title for your graph, so the temperature of heated water. You always need to label your axis with both units. So we have minutes here and degrees Celsius here. And you need to tend to have at least 3 plot points. In this case, we have 6. Valid. I will not assume untrusted data is valid. I will not assume untrusted data is valid. I will not assume untrusted data is valid. Valid. What makes something valid? Well, for an experiment, you must follow the scientific method. You must record and document all findings so that the other scientists can test, and retest, and get the same results. And you must have a control group, which is the group that does not receive the experimental treatment, so that you can compare between your control group that didn't have anything change and your experimental group, which had your one variable change, so that you can compare. And you only can have one variable. One. Uno. What is the difference between a law and a theory? Well, we've already got a hypothesis, which is an educated guess. A theory is an explanation of events supported by a wide range of evidence. It explains the why, how, and the actual mechanism. Now, a law is a phenomenon that is observed over and over again in nature. It's just an observation. It does not explain how or the mechanism. So let's take into consideration gravity. We have the law of gravity and the theory of gravity. Well, when we're just talking about the law of gravity, I bet you can help me out with this one. What goes up must come down. And that is the law of gravity. You can do it again and again. It doesn't tell you why it went up, or why it came back down, or how. It just tells you that it does. Now, the theory of gravity goes into mathematics and gravitational forces and the masses between objects and how they interact. That's going to tell you the why and the how and the mechanism. But the laws don't. Remember, the laws are just an observation that's seen in nature that happens over and over again. What goes up must come down. Okay. Now, to successfully pass this class, you must become a responsible, an ethical, and a balanced scientist. And that's all I have for you today. Bye.